In this session, we are trying to build the machine learning model for movie rating predictions. So among all the machine learning models we have, first we are trying with linear regression model. So here the linear regression is stored in the variable lm, and here we have used the model.predict for xtrain and xtest data, that is lm.predict xtrain and lm.predict xtest. And in order to evaluate the performance of this model, we have used the evaluation matrix in order to see how well this model has performed. And the evaluation matrix that we have used over here is root mean squared error. So what we have done is that we have just clicked on the root mean square on the y-test data and y-train data. So here we have used np.square root on the mean square error with y-test and y-train. And then we have printed the corresponding values, and this line of code is used to print a dotted line which separates the root mean squared error values and the root squared values. So let us run this cell first. So here we can see that the RMSE, that is the root mean squared error for training data, is 12, and for test data it is 11. And the root squared value on the train is 40. Similarly, the root squared value on the test is 40. The R square value on the data must be higher. So closer to 100, the better demand. As you can see, the lower or closer to 0, the better the model. And as you can see, we have printed the R square value on X train and Y train data. And the R square value on the test and the train has been printed over here. So the RMSE value is 12, as well as the RMSE on the test data is 11. But as you can see, the R square value on the test data is 40 and the value on the train is 40 again. So this R square value must be improved, and we have to basically increase the R square value. So far this model is not very good, but next thing we have done over here is we have calculated the error. And then here we have calculated the mean absolute percentage error with the following formula. So the mean absolute percentage error is equal to 100 into error divided by the y-test value. And the accuracy is 100 minus np dot mean of the mean absolute percentage error. And we have printed the accuracy here. And the accuracy over here is 95.5%. The next model is decision tree regressor model. So here also we have the model.predict on xtrain and xtest data, that is a decision tree regressor.predict on xtrain. Similarly, decision tree regressor.predict on xtest data. So here also we have calculated the root mean square error for y-train and y-test predicted data, and then we have printed the values. So let's run this cell. So here the RMSE training data value is 8 and the RMSE test data is 12, and the R square value on the train data is 71 and on the test data it is 37. And here we have calculated the error. Next we have calculated the mean absolute percentage error and the accuracy. So here also, using this decision tree regressor, the accuracy is 95.52, which is slightly more than the linear regressor. The next machine learning model that we are going to use is a random forest regressor. So here also we have predicted the train and test values, that is rf.predict xtrain, rf.predict xtest, and again we have printed the values using np.square root for both the train and test values. And here we have printed the values, that is the root mean square error values and the root square value on train and test values. So let's run this cell and see the values. So here the RMSE on training data is 4 and the RMSE on the test data is 9. R square value on the train data is 92 and R square value on the test data is 57. Again we have calculated the error. Next we have calculated the accuracy. So So the accuracy is 96.29%, which is more when compared to the decision tree and the linear regression model. The next model we are going to build is k nearest neighbors. So here also in the same way we have printed the values for root mean square error for training data and test data, and we have printed the root square value for training and test data. So let's run this cell. So here the RMSE on training data is 10 and the RMSE on the test data is 13. R square value on trained data is 51 and R square value on test data is 26. So here also the values are not very good and we have a lower R square value on train and test data, and this model is performing very badly. And so far we will stick to the random forest regressor, which has performed very well. And here we have used other machine learning models also, that is lasso CV, rich CV, elastic net CV, gradient boosting regressor. So in order to build this model, we have to import some libraries. Let's run this cell. So here we have imported the required libraries to build a few more machine learning models. So here for lasso regression also, in the same way we have defined the RMSE train value and the RMSE test value, and we have printed those values, RMSE training data, RMSE on test data, similarly R square value on train data and R square value on test data. So let's run this cell. So the RMSE value for training data is 12, RMSE value for test data is 11, and the R square value on the train is 39 and the R square value on test is 40. The next machine learning model is rich regression. So in the same way here also we have calculated the value of RMSE for training data, RMSE for test data, and R square value for train and test data. So let's run this cell. So these are the values that we got. Similarly for elastic net also. So this is also one of the machine learning model. So here the RMSE training data is 12, the RMSE test data is 11, the R square value on train is 39 and the R square value on the test is 40. So till now, whatever machine learning models we have used, among all those the random forest regressor is on the top. We'll try for another machine learning model, that is XGBoost regressor. So let us run this cell. Here we can see that the RMSE training data is 9 and the RMSE test data is also around 9 only. So which are very less values. So which are a very low value. So which is a very low value. And here we are having a good value of R square, that is 64 and 58 on train and test data respectively. So here let's calculate the error, and here we will be calculating the accuracy. So here accuracy is 96.32. When we compare this to the random forest regressor model, so for random forest regressor model, the accuracy is 96.29%, whereas for XGBooster model it is 96.32. But so far we can see that when we compare these models with their R square values, the R square value over here in XGBoost regressor is 64. The R square value on the XGBooster regressor is 58 on the test data. And back to the random forest regression, we can see that the RMSE value on the test data is 57. So we can clearly see that XGBoost regressor has performed very well even when compared to the random forest regressor. So even though the random forest regressor has performed very well, but we can say that accuracy over here is a little bit higher as compared to the random forest regressor. And this model can be used in order to predict the IMDb score ratings. And the more you can be further improved with the help of the hyperparameter tuning, and we can tune the hyperparameters as XGBooster regressor and random forest regressor, and see if there is any increase in the accuracy of these models or not, and see if there is any increase in the accuracy of these two models. But for now, this is the end of the video. This is the end of the project. Till then, happy learning.